My name is Roberto, and today I'm going to do some experiments that explain the Charles law, the Gay-Lussac law, Avogadro's law, and the ideal gas law. The Charles law is how the volume of a gas changes with temperature. The Gay-Lussac is how the pressure of a gas changes with temperature. The Avogadro's law is how the volume of a gas related to the amount of gas that is moles, when temperature and pressure are constant. And the ideal gas law is a combination of all the simple gas laws in one equation. It relates pressure, volume, temperature, and number of moles. Okay. For the first experiment, I will explain the Charles law. I will have to use some can or two. This a bowl of water and a bowl where I'm going to have ice or cold water and something to heat the can. Okay, so first I have to drop 100 millimeters to the can. Okay, and after that I'm going to heat this can for like a minute. You can see here vapor is steaming out of this can, so I'm going to drop it out. I'm going to drop it in cold water. The can crusher experiment demonstrates the Charles law because the gas inside the can changes volume when its temperature changes. And when the can is heated, the water vapor inside expands, showing that gas is increasing volume when heated. When the can is suddenly cooled, the vapor condenses and the gas volume drops very fast. Second experiment, we are going to show how the Gay-Lussac's law works. And for this experiment, we'll use a bowl with water, two candles, a food coloring, matches, and a spoon. So first we have to put the two candles inside the bowl with water, and no, my bad. We have to first drop two drops of coloring. One, two, and mix it with the spoon. Okay, now we will have to put the two candles inside, and we are going to fire them with the matches. And after this, we have to put this glass inside the two candles, and as you can see, the water is increasing, but the two candles apagarse. Candles are put inside the glass. The air inside heats up slightly at first. According to the Gay-Lussac, if the temperature rises, the pressure inside the glass also increases. This pushes the air out a little, but the initial effect is small. When the candle goes out, the oxygen is consumed and the air temperature decreases. According to the Gay-Lussac, as the temperature drops, the gas pressure decreases. The pressure inside the glass becomes lower than the external atmospheric pressure. The water rises to equalize the pressure because now the external pressure is greater than the internal pressure. Hello, for the third and last experiment, we will be explaining the Avogadro's law. And for this experiment, we'll use two balloons, a baking soda, vinegar, a measuring cup, two plastic bottles, and a spoon. So first, what you have to do is drop 100 milliliters of vinegar, and we will have to put it in the plastic bottle. Okay, so now in this balloon I have to put two yes, okay, one and two. You have to mix it really good. I think this is the hardest part of the experiment. Okay, so after the 2 tablespoons, I'm going. Wait. I'm going to put the balloon inside the plastic bottle. I'm going to put it like this so the baking soda doesn't drop. And now I will drop the baking soda. Wait, no. Yeah, now. Oh, and this is the reaction. Okay, so now to get better results and to get a comparison, we will do the same, but instead of 2 tablespoons of baking soda, we will drop 4. So in this one, first we have to put the 100 milliliters of vinegar. Okay. After this, we're going to put the balloons. And after that, we have to place 4 tablespoons of baking soda. One, 2, 3, and 4. Have to mix it really good, because this, I think, is the hardest part of this. I almost got it. Okay, so now for the final step, we will mix the 4 tablespoons of baking soda with the vinegar. Well, as you can see, this is the one with 2 tablespoons of baking soda, and in my opinion, I think they are like same size, or I think this one is a little little, but I think they are really the same. Baking soda mixes with vinegar, it makes carbon dioxide gas. This gas goes into the balloon and makes it inflate. The more baking soda you use, the more gas is produced and the balloon gets bigger. This shows Avogadro's law, which says the more gas moles you have, the bigger the volume of the gas. So basically, the more moles of carbon dioxide gas you have, it will show in depending in the balloon, it will become bigger.